Okay, guys, welcome. Today we're going to talk about the principles of correlation and causality. Now, first I want to talk about what we mean when we are seeking a correlation. Now, a correlation exists between two variables when higher values of one variable consistently go with higher values of another variable, or when higher values of one variable consistently go with lower values of another variable. Right? So just as a couple of examples, there is a correlation between the variables height and weight, right? Because taller people tend to weigh more than shorter people. So we would say that height and weight are correlated. There's also a correlation between the variables, the demand for apples and the price of apples, right? So sort of supply and demand showcases another correlation relationship there. Right, and the reason why is because demand tends to decrease as the price increases. And of course, as one last example, there's a correlation between practice time and skill among piano players, right? Because those that practice more would tend to be more skilled. Now, just because a correlation exists between two variables, it doesn't necessarily mean that one variable causes the other, right? So now in each of these examples, the correlation is usually a result of one causing the other, right? But that doesn't necessarily have to be the case, right? And we'll sort of get into that in a little bit. Now, one thing that's often used to identify correlation is a scatter plot. Now, of course, each point on a scatter plot would represent the values of the two variables, right? So we're going to look at a couple of the different graphs that are from the book, and then we'll talk about the different type of correlation that they exhibit. Now, in this first one, we have the U.S. Gross earnings of some top movies that were produced, and this is based on the production cost, right? So we have, for example, they're showing that Prince Caspian was here, and that had a budget of around, it looks like between 200 and 250, so maybe around 225, and it earned a little bit below $150 million, right? So what you could do is you could say that, and it would be hard to sort of draw it on here, but you would want your receipts to be much bigger than your production costs, right? So that you can make a profit. Right. So it seems like that this is somewhat positively correlated, because you would hope that as the production increases, the production costs increase, you would hope that the receipts on the movie would increase, but of course that's not always the case. Right. Now, this next graph gives us the scatter plot for diamond weights and prices. And of course, here you would think that the heavier a diamond is, the more expensive it would be, and that does seem to be the case here, right? So you have this general trend of going up. Now, the last graph here, the last scatter plot that we have, is showing us the life expectancy in years for certain countries, and they compare that with the infant mortality also. Right. So of course it would make sense that the life expectancy would be higher in countries where the infant mortality is lower, right? So it looks like, as the life expectancy increases, the infant mortality goes down, which is what we would expect. Okay. So of course, there are different types of relationships between two data variables that we've sort of talked about a little bit, but let's be a little bit more specific now. Now, you have that two variables are positively correlated if both variables tend to increase or decrease together, right? So as one increases, the other one increases, or as one decreases, the other one decreases, would be an example of positive correlation. And for the most part, those graphs would look something like this, right? You have the data points going on the way up. Now, negative correlation would be that the two variables change in opposite directions. As one increases, the other one decreases. So that would look something sort of the opposite. You'd have, in general, one going down as the other goes up. Now, if there's no correlation, that means that you don't have any apparent relationship that's evident. You just have sort of points all over the place, right? And it would be hard to tell what the correlation would be. Now, the strength of a correlation can also be measured, and you have that the more closely two variables follow a general trend, the stronger the correlation will be, right? And of course, if you have the best correlation possible, that's when all data points lie on a straight line. So the more that your data on a scatter plot looks like a straight line, we would say that the more strong your correlation is. Okay. Now, in this next example, we're saying that prior to the 1990s, most economists assumed that when unemployment rate and the inflation rate were negative correlated, right? So when unemployment goes down, inflation goes up, and vice versa. Now, this table that we have from the book shows unemployment and inflation data for the period 1990 to 2012. Now, it says to make a scatter plot, but we have one that's given to us because these are a lot of data points, so I just copied that in here. And based on the diagram, does it appear that the data support the historical claim of a link between the unemployment and inflation rates? Right, so this is your table for the unemployment rate against the inflation rate. And this is what the table that, the scatter plot that would result from plotting that table. Now, it actually appears that if we look at this, there doesn't appear to be a correlation at all, actually. So with this, we might say is not that there's no correlation, right? Because it's hard to say whether or not your points are generally increasing or generally decreasing. So here we would say that there's no correlation. Okay, now in the next example, we have that the scatter plots in figure 5.41 on page 346, which I've copied here, show 2 weeks of data comparing the actual high temperature for the day with the same day forecast and the 3-day forecast, which will be on the right? And we'll discuss the correlation on each diagram. Now, it looks like the correlation for this first one is positive for sure, right? It might be weakly positive, but it's a positive correlation. Now, if you look at the 3-day forecast, it still appears to be positive, but it's sort of more far away from that line, right? So we would say that both are positively correlated. But this one is probably a stronger correlation. All right, so that's the idea when we say stronger or weak correlation. Okay, now there are some explanations for a correlation, right? So the first one is that it might just be coincidence, right? The second one is that both variables might be directly influenced by some other common underlying cause. And then the third one is the one that we're generally most interested in proving, and that's one of the correlated variables may actually be a cause of the other, right? Now, note that even if this is the case, it might not be the only cause, it just may be one of several causes. So it's something to keep in mind. Okay. Now consider the correlation between infant mortality and life expectancy, which is the graph that we already looked at. Now, which of the three possible explanations for a correlation applies? Okay. Now in here, we have that this is, again, so the life expectancy, as that increases, the infant mortality is going down, right? And of course, it's definitely possible that three, where one is causing the other, is the case, but it's only one of several causes, right? So here, infant mortality will definitely contribute to life expectancy. Because that will factor into the average of the life expectancy. But of course, it's also a product of the living conditions, it's a product of the availability of medicine, and so on and so forth, right? So those are other things that we would need to consider. Okay. Now, in this next example, we're going to talk about um, how this is also um, how we can also have coincidence coming up. Now, every financial advisor has a strategy for predicting the direction of the stock market. Most focus on fundamental economic data such as interest rates and corporate profits. Now, an alternative strategy relies on a remarkable correlation between the Super Bowl winner in January and the direction of the stock market for the rest of the year. The stock market tends to rise when a team from the old pre-1970 NFL wins the Super Bowl and then tends to fall otherwise. This correlation successfully matched 28 of the first 32 Super Bowls to the stock market, which made the so-called Super Bowl indicator a far more reliable predictor of the stock market than any professional stockbroker during the same period. Now, suppose that the Super Bowl winner just ended and the winner was Detroit Lions, an old NFL team, right? So I don't think you have to worry about this anytime soon, but we're just going to suppose for the sake of argument that the Detroit Lions did win the Super Bowl. Now, should you invest all your spare cash and maybe even some that you have to borrow in the stock market? And of course, the answer here, of course, is no. And because this is all just a coincidence. Right? Even though it's sort of a remarkably accurate coincidence, there's no telling to um, that it will be just as accurate for the next time, right? So the fact that it's a coincidence is something that you have to keep in your mind. So let's talk about some guidelines for establishing causality. So you have a correlation and you want to see whether the one variable is causing the other variable to happen. Now, if you suspect that a particular variable is causing some effect, here's what you can do. So first, you look for situations in which the effect is correlated with a suspected cause, even while other factors vary, right? So in other circumstances, where both of these variables are still present, do you also see the same sort of correlation? Now, second, among groups that differ only in the presence or absence of the suspected cause, we would check the effect and see if that is similarly present or absent. Okay, three, look for evidence that larger amounts of the suspected cause produce larger amounts of the effect. Four, if the effect might be produced by other potential causes besides the cause, make sure that the effect still remains after accounting for these potential causes. Five, if it's possible, you would want to test suspected cause with an experiment, right? Now, if you can't perform the experiment with humans for ethical reasons, you can either use cell cultures or computer models or animals if that's also ethically safe as well. And then, of course, the last thing, try to determine the physical mechanism by which the suspected cause produces the effect. Okay. Now, there's three broad levels of confidence in causality, and this will be what we end this video on. Now, we have possible cause, which is when you have discovered a correlation, but you cannot yet determine whether the correlation implies causality. So cannot yet determine if one implies the other. Now, in the legal system, possible cause, which would be an example of like thinking that a particular suspect possibly caused a particular crime, is usually the reason for starting an investigation, right? So I think that a lot of these things have nice parallels to the legal system, so we'll sort of comment on that as we go. Now, the next one is probable cause, and that's where you have good reason to suspect that the correlation involves cause, perhaps because some of the guidelines for establishing causality are satisfied. Now, in the legal system, probable cause is usually the general standard for getting a judge to grant a warrant for a search. Okay. Now, the last one is that we have found a physical model that is so successful in explaining how one thing causes another that it seems unreasonable to doubt the causality. Now, in the legal system, cause beyond reasonable doubt is the usual standard for conviction, right? It generally demands that the prosecution show how and why the suspect committed the crime. Now, of course, one thing to keep in mind is that beyond reasonable doubt does not mean beyond all doubt, right? So again, it's one of those things where it's not a 100% guarantee in most cases, but beyond reasonable doubt is sort of the key there. All right, well, that concludes this video on correlation and causality. I hope you enjoyed, and I'll see you next time.